Hello folks, we're going to talk about aerofoils today. What they are, what kind of shapes they have, what are main parameters of aerofoils, and where do we use them. To start with the general description of the airfoil, it is a streamlined shape optimized specifically for having minimum drag while having some kind of thickness. So if you imagine a ball and a flat plate, it's somewhere in between, basically. The main parameters of the airfoil, let's start with the leading edge, which is located literally in the most forward point of the airfoil, and the trailing edge, which is at the most back point of the airfoil. There's a chord line, which is the line in between those 2 points. An airfoil has two surfaces, a lower surface and the upper surface. Also, these surfaces are called pressure side for the lower surface and the suction side for the upper surface. As you might know, while aircraft flies, increased pressure is below the airfoil and the decreased pressure is on the top of the airfoil, and that's why these names are coming from. Also, really important parameters are, first of all, the camber line. And to describe what camber line is, imagine if you divide lower surface and upper surface with equal amount of points and make lines on those points, then find the middle points on each line, and from the leading edge to the trailing edge, through all of those points you create some kind of spline, you will get actually the camber line, which describes what kind of camber the airfoil has. In case of symmetric airfoils, there are no any kind of camber actually, but you should know the concept in general. Another important parameter is the maximum thickness of the airfoil. So along the chord line, you will have a point where airfoil will have the maximum thickness, and that's what we call max thickness. And also there is a max camber point, which is also along the chord line, a point where distance between chord line and the camber line becomes the highest. These parameters you will need in future to describe some airfoils we will cover in following videos. The most common types of airfoils, what you're going to find is first of all the symmetric airfoil, which has symmetric shape, or asymmetric airfoil, which has non-symmetric shape. Another variation of asymmetric airfoil, which has the flat bottom. Also, so-called stable or S-shaped airfoils, which are mostly used for flying wings. They have so-called reflex at the trailing edge. If you notice among these airfoils, exactly the fourth one has the reflex at the trailing edge, so its trailing edge looks somewhere up. And those airfoils are commonly used for specific type of aircraft where you need to avoid using tail plane or any kind of stabilizer, and is basically stabilizer in somehow inserted into the airfoil. And the high camber airfoils, which are mostly used for gliders or any kind of aircraft which requires high gliding ratio or high lift capabilities. And where do we meet airfoils? First of all, obviously, aircraft wing. If you see the cross section of the aircraft wing, it has some kind of airfoil shape. It depends on the aircraft. Also, wind turbine blades have airfoil shapes. Helicopter blades or any kind of propeller blades, or even blades of jet engine. All of them have airfoils specifically designed or optimized for those regimes where they have to work. So this was a brief description of airfoils. In the following video, we're going to have a look on a specific airfoils, some databases where we can see the list of airfoils mostly used. And then on the channel, we're going to cover some airfoil analysis to actually perform aerodynamic analysis. Thanks for watching. Please subscribe.